Welcome back. In the previous lecture, we have discussed about the different systems which are referred to as infrastructure, and we have also seen the taxonomy of infrastructure. In the present video lecture, we will concentrate on the vulnerabilities of the infrastructures. At the end of this lecture, I hope you will be able to explain the impact of disasters on various infrastructure systems like the treatment plants and the process facilities, the transportation systems, and the electrical substations, which are part of the energy systems. We'll start with the treatment plants and the process facilities. We will see what the impact of disasters on treatment plants and process facilities. We will go through the different components of these plants. We will see what the vulnerabilities which they do face. And finally, we will deal with the systematic designs. Now, when we are discussing the treatment plants and the process facilities, these include the drinking water systems, the sewage water systems, the oil refineries, the chemical plants, and the industrial facilities. And all these facilities include extensive pipelining, basins for storage, tanks for storage, processing units, control buildings, stacks, and chimneys. All these components are essential parts of these treatment plants and process facilities. And all these components, they are exposed to disasters. So all of these things are part of these things may get damaged when a disaster is happening. When we consider the equipment in the plants, these are vulnerable to foundation settling, especially when founded on fields, and when they are placed on differential settlement of adjacent structures and components. Similarly, coming to the pipes, as you all know, these pipes are spread over the entire plants. They will be carrying some different materials. Now, when they get connected or when they penetrate a treatment structures, then they may get damaged. And regarding the pumps, they get damaged by the loads imposed by piping when there is a differential settlement. And coming to the channels or underground structures or concrete basins, all these things, particularly the underground structures, whatever the underground structures are there, they may get liquefied in areas where high groundwater is supposed to float. And coming to this concrete basins and tanks, these may be subjected to the seismic damages, particularly due to the cracking and collapse of the walls and roofs. These concrete basins and tanks and all these equipment, the pipes and pumps and the underground structures, they all may get damaged due to the cracks of the walls, or sometimes collapse of the walls also. So one or the other, all these equipment, these do have vulnerabilities. Now these are few damages which have been experienced at different parts due to the earthquakes. See, the oil tanks have been damaged, the pipes and the bucklings of the steel tanks have been damaged. So all these things, they might get damaged due to one or other natural disasters. Now, there are other vulnerabilities in these treatment plants also. Just like the joints may be expanded in the basins, and the anchor bolts and support members, they may experience a shaking and they may get damaged, and any suspensions from the walls or from the roof, they may fall off because of cracks or falling of the roofs. And any equipment which is not properly anchored, which is not properly supported, It may slide or it may topple and may cause damage to the nearby equipment like the piping or any other conduit, etc. And most important thing, if there are any transformers nearby, and damage to substation transformers may result in loss of power supply also. So these are the different vulnerabilities which you experience in treatment plants. So there is always a need for seismic resistant designs, because most of the times, particularly when discussing about the earthquakes, which are one of the disasters which cause extensive damage to the infrastructure. So it is advisable to practice or to consider the seismic resistant designs when you are planning the construction of these plants. So coming to the seismic resistant designs of water treatment plants or all the treatment plants, they must provide capability to bypass plant treatments and to provide emergency chlorination in the event of damage caused by an earthquake. So this is the main aim of seismic resistant designs. They are supposed to provide capability to bypass the plant treatments and to provide emergency chlorination in the event of damage caused by the earthquakes. And you can go through all these points. These are to be followed for the treatment plants. Our concern is mainly upon the water treatment plants, so you can go through them. And next topic is on electrical substations. You all know that electrical substations are a very huge part of the infrastructure in the energy sector. These substations, they will be at the generating ends, transmission ends, and also at the distribution ends. In all parts of the power transmission, we can see these electrical substations. These are spread over a large area, and they includes the conductors and different switchgear. Now, if you carefully see, the shown in the figure is a typical substation, electrical substation. It is just like the terminal of electrical transmission lines and provides switching and voltage transformer functions. It basically consists of open area which is fenced and with overhead buses supported by some steel or concrete structures most of the times. And the different equipments in the electrical substations and the possible damage, what we call it as vulnerabilities, are the first one being the control building of these substations. It may experience some sort of any damage from any suspended particles which are there to the ceilings, or it may experience some cracks in the walls and frames, which may result in partial or total collapse of the control station. There will be control equipment in these control substations. It may slide, these control equipments, it may slide or topple, experiencing damage or causing attached piping and conduit to fail if it is not properly anchored. And coming to the yards where there are steel towers, because of the earthquakes, there may be soil failures which may damage these steel towers which are there in the open yards. And there will be this porcelain bushings and insulators and lightning arresters in the substations, which may get damaged due to the extensive shaking because of these earthquakes. And there will be transformers too. These transformers, the radiators of these transformers may get damaged, their bushings may be broken, and there will be oils inside their tanks, it may get spilled out, and any wirings to attach it to that, it may get damaged. So all the conductors and the bus bars, if they are rigid in structure, they may result in porcelain damages because of the differential motions. Now, what are the measures which are to be taken to avoid the seismic damages? The first one being In the latest market, in the past 50 or 60 years, gas insulated substations have come into enforcement. So it's better if you use gas insulated substations when compared to the conventional air insulated substations, where we do employ this porcelain insulation. This will be lighter and it requires a small amount of space. Or else you can use damping devices for porcelain, and you can take a care about this proper anchorage of the equipment. You are supposed to avoid the friction clips, and you are supposed to provision of conductor slack between equipment in the substation, and you always need to have breakaway connectors to reduce the loads on porcelain bushings and insulators, and you are supposed to maintain some adequate space between the equipment to reduce the secondary damages, because if there is any damage, immediately the equipment will fall onto the next equipment which is present there, and this is called as a secondary damage. So one equipment damaged falling onto the next equipment, thereby creating additional damage. So you are supposed to avoid such sort of damages by maintaining some space between them. And this structures, building structures, they are supposed to follow the national codes, as we have seen already in the building codes units. So try to follow this local national building codes. And consideration of flood in engineering design is also required most of the times. So these are the measures to be taken to avoid the seismic damages. And moving ahead, coming to the transportation system, this is a structure of a transportation system. What you call, see, this is a bridge, and here if you can see these pillars type of structures which are made of steel or concrete, and these are called as pile caps. These are spread footers. This is a different equipment, different components of a bridge basically. So if any of these components gets damaged, then the entire bridge may get dislocated and it may not be suitable for transportation. So you are supposed to take care of all these components. See, this is a falling column which you might experience in case of a natural disaster. This is score damage at the end of the roads. See the roadbeds in the bridges. These basically include the embankments, the pavements, the draining structures, signaling and lighting structures and equipment. These are basically employed in highways and railway systems. They can be straight, they can be skewed, fixed, mobile or floating bridges. Different types are available in the market. Most of the equipment is made up of this concrete, steel, wood, etc. Particularly the foundation systems for the bridges basically. They include, as you have seen, footings will be there, piles will be there, piers will be there. So all these are the components of your bridges. And these are the different vulnerabilities which you do have. There will be different types of disasters, particularly when there is an earthquake. This roadbeds and bridges. See, particularly to the roadbeds, the underlying ground may undergo permanent ground displacements due to the landslides. So for that, what you are supposed to do, you are supposed to employ adequate geotechnical engineering with proper grading and compaction to maintain your roads. Coming to the bridges, there may be a loss of beam when you experience an earthquake or a heavy cyclone. The beams below the bridges, they may get misplaced. So for that also you are supposed to plan properly. If there are gusty winds and onto the roads, there may be huge amount of debris. Whereas for the signaling towers, if you see, electric lines get short circuited. So for all these things, you are supposed to follow the building codes and you are supposed to have some additional features, protection features. So you please go through all these things. And for different types of disasters, for different structures of the transportation systems, these are the vulnerabilities and the remedies which you can follow to minimize the damages. And coming to the conclusions, survival and rapid recovery of different types of infrastructure service systems is very critical to reduce the impacts of the disasters. And all the existing infrastructure is to be upgraded so that its post-disaster performance is going to be acceptable. And coming to the assignment, I hope you go through the assignment and submit it before the due time. Thank you.